Hello, everybody. Welcome to today's lecture. So last time we talked about chapter 2.3 and 2.2. So we started talking about equations, and these are really important. So definitely get some practice in on these. They'll be on the next homework assignment for sure. Let's do a couple more examples here before we move on. Actually, just as a reminder of how to do these, because like I said, these are really important. So I'll just make up a couple. Let's say we have 103 plus y equals 205. Okay. So notice I'm using y here. I was typically using x, but we can use any letter to represent a variable. Okay. So we want to know exactly what y is. There's only one possible thing it can be. There's only one thing we can add to y to get 205. So there's a couple ways you can approach this. One, you could just kind of guess and check, right? You could kind of just think about it. But when you're doing that, probably what you're actually doing in your head is the proper method. You just don't really realize that's what you're doing. So the proper method is to look for something you can subtract or add on both sides. Here we want to know what y is. So we want a statement that says y equals blank. The only thing stopping us from having that statement is that 103. So if we just subtract 103, then we'll just have y on this side, right? Because 103 minus 103 is 0. But we can't just subtract it on one side. Anything we do to one side, we have to do to the other side also. Okay. So we can subtract 103 from both sides. So that's what this property up here said, the subtraction property of equality. So when we do that, over here we just have y, because 103 minus 103 is 0. 0 plus y is y. Now over here we can do the subtraction. So, I mean, we can just, it's already set up, so we can just do it like this. And we get 102. So y equals 102 is our final answer. Okay. Another example would be if we have like a minus 44 equals 67. Okay. Now, same idea. We want to just have a by itself. Well, the only thing stopping us from having that is that we have a subtract 44 here. The opposite of subtraction is addition. So if we add a 44, that'll cancel out the subtraction, and we'll just be left with a, right? So we want to cancel out whatever we're doing here. Just like with this, a positive 103, we subtracted 103 to get rid of it. But we have to do that to both sides. Again, right? We can never do anything to just one side. We have to do it to both sides. So now we have a on this side, and over here we get 111. Okay. Now, if you want, you can always take that 111, plug it back in, make sure you get the right answer, right? Because if 111 is right, that means we subtract 44 from it and we get 67, right? So you do all your borrowing and you get what am I doing wrong? Oh, this is why you should write out the borrowing, right? We try to borrow from this one. Oh, I'm sorry. I didn't need to double borrow. That's what the problem was. All right. So we borrow from this to make this 10. Sorry, we'll make this 11. All right, because we're adding 10 to it. And we already have this one. So we borrow from this, we make it 11, we get 7. And now we want to borrow for this one, and we get 0. And we add that 1 onto it. 10 minus 4 is 6, so we get 67. So it does check out. Alternatively, at this point, you can just put in a calculator if you'd like. So this is the idea. We want to either subtract something from both sides or add something to both sides. Later, we're going to see we're going to be able to multiply on both sides, divide by both sides, square both sides, square root both sides, a whole bunch of different stuff. So let's move on to 2.4 now. 2.4 and 2.5, we want to deal with kind of the last two key things involving whole numbers specifically. And then after that, we're going to get into the integers, meaning that we're going to add negative numbers into the mix. So this section is called Find Multiples and Factors. Okay, find multiples and factors. So multiples means that, well, here, let's just write down the definition here. Okay. A multiple of a number is the product. Remember, product means multiplication. Is the product of the number, so whatever number we were talking about, and a counting number. Counting number meaning like 1, 2, 3, 4, etc. Basically any whole number except for 0. Okay, if we take a number and multiply it by 0, we get 0. So we don't consider 0 to be a multiple of every number. So for example, multiples of 2, we would have 2, 4, 6, 8, 10, etc. Because this number is 2 times 1, so it's the product of 2 and the counting number 1. This number is 2 times 2. This number is 2 times 3. This one is 2 times 4, 2 times 5, etc. So you take 2, you multiply it by 1 in the counting numbers, you get a multiple. So it's essentially just counting by that number. So if you've ever like counted by 2s, counted by 3s, counting by 5s, you're listing the multiples of that number. Okay. So let's look at some more examples, like 3 multiples of 3. We'd have 3, 6, 9, 12, 15, etc. Right? If we wanted to look at multiples of 5, we just count by 5s, right? 5, 10, 15, 20, etc. So we're just taking the number and counting by that number. So we have like 5 times 1, 5 times 2, 5 times 3, 5 times 4, etc. Like I said, we don't consider 0 to be a counting number, so 0 is not a multiple of all these numbers. Multiples of 1, every number is a multiple of 1. So we could write that out. We just don't typically talk about it. Because if you count by 1s, I mean, that's just normal counting, right? In section 2.4, there's a table where it lists all the multiples of 2 through 9. So if you want to look at that, and it lists them all the way up to the 12th multiple. So when you multiply the number by 12, so it's a nice table. So definitely take a look at that if you want some more examples. one thing that we're going to be interested in is how do we determine if a number is a multiple of this? Okay, so what if we're given a number, say like 33, and we want to know, is it a multiple of 2? Okay. Or is it a multiple of 3, or is it a multiple of 5? There's certain patterns we can look for to determine this without having to list out all the multiples of 2 up to 33. Like notice for 2, all of the numbers are even. Okay. 33 is not even. For 3, it's not as straightforward. Okay, 5, there is a pattern. All of the numbers either end in 5 or 0. So it's not, 33 doesn't end in 5 or 0, so it's not going to be a multiple of 5. When we're asking if something is a multiple of something, we often rephrase it as whether or not a number is divisible by something. So saying, is 33 a multiple of 2? Another way of phrasing that would be, is 33 divisible by 2? Okay. So another definition, if a number m is a multiple of n, then we say m is divisible by n. Okay. So it's just kind of like reversing the language in the same way you do with multiplication and division, right? Saying like 3 times 5 equals 15. You just kind of flip that around and you can say 15 divided by 5 is 3. Same thing here. If 12 is a multiple of 2, then we can say 12 is divisible by 2. Okay. So listing out the multiples, it's not usually something that's super useful. We're just counting by that number. But if we're given a number, asking whether or not that's divisible by another number could be very useful. For example, like let's say we have like a bunch of something and we're trying to share it with a group of people, and we want to know whether or not we can do that evenly, right? So let's look at some common divisibility tests. Okay. Divisibility test. So this is a test for whether or not a number is divisible by whatever number we're talking about. Okay. So to test if a number is divisible by 2, well, like I said, all the numbers that were multiples of 2, they were all even numbers. Okay. So what does it exactly mean to be even? We never really talked about like what even versus odd is, right? By definition, even just means that it's a multiple of 2, so that's not really helpful. If it's even, but what does that really mean? Meaning if its last digit is 0, 2, 4, 6, or 8. Okay. So a number is even if it ends in 0, 2, 4, 6, or 8. And then that means it would be odd if it ends in 1, 3, 5, 7, or 9. So if we're talking about whether or not a number is divisible by 2, we're looking to see if its last digit is 0, 2, 4, 6, or 8. Okay. So this one's a relatively easy divisibility test to do because all we have to do is look at the number. We don't have to do any more work than that. So if we wanted to look at, for example, 33, right, we can just look at the last digit. The last digit's 3. That's not one of the ones in our criteria. So we know that 33 is not divisible by 2. Okay. So let's say 33 is not. We can even do this with, really big numbers. It doesn't really matter how complicated they are. All we have to do is look at the very last digit, right? So here the last digit is 1, so we know it's not divisible by 2. So 2 is not too bad, right? We can just kind of just do it visually. 3 is a little bit different. 3, you actually have to do a little bit of work to test. Okay. So a number is divisible by 3 if the sum of its digits is divisible by 3. Okay, so this is kind of a weird one at first sight. We look at the sum of its digits and look at if that sum is divisible by 3. Okay, this is kind of surprising. So for example, if we have something like 33, we want to look at the sum of its digits. So we want to take each individual digit and add them together. Okay. The sum of digits is 3 plus 3, because we're adding this digit to this digit, equals 6. And we know 6 is divisible by 3. That was on our list earlier of multiples of 3. Right. So 33 is divisible by 3. Okay. What about this number up here? This really big number. This is 1,101,101. Okay. We can tackle even really big numbers like this because all we have to do is add the digits together. Okay, so the sum of digits equals 1 plus 0 plus 0 plus 0 plus 1 plus 0 plus 1 plus 1 plus 0 plus 1. So we have 1, 2, 3, 4, 5 numbers here that aren't 0. So we get 5. Right, we have 5 ones, and then the rest are zeros, and the zeros aren't adding anything. So we end up getting 5 as our sum of digits. Well, 5 is not divisible by 3. That wasn't on our list of multiples of 3. So this number is not divisible by 3. Okay. The book doesn't talk about it, but the same idea works for 9. A number is divisible by 9 if the sum of its digits is divisible by 9. So, for example, 33 is not divisible by 9 because 6 is not divisible by 9. And since we know this isn't divisible by 3, it's not going to be divisible by 9 either. You can kind of stack the rules on top of each other like that. Like for telling if a number is divisible by 4, instead of looking at its last digit, you're looking at another way of phrasing this one is that it's divisible by 2 if its last digit is divisible by 2. 0 is going to be divisible by any number. You can do the same thing with 4, but you just extend it by 1 digit. So a number is divisible by 4 if its last 2 digits are divisible by 4. And then you could do it with 8 also. A number is divisible by 8 if its last 3 digits is divisible by 8. And then you could go 16, 4 digits, 32, 5 digits, etc. Those are like the powers of 2 if we just kept multiplying 2 by itself. So same thing with 3, 9, 27 if we multiply by 3 again. A number would be divisible by 27 if the sum of its digits is divisible by 27. Okay, so we're just going to look at these small numbers, but that's how we can look at some bigger numbers if we wanted to. In fact, if we think about the number 6, okay, 6 is 2 times 3. Okay. In order for a number to be divisible by 6, it has to be divisible by both 2 and 3, because that's how we make up 6, right? So all we have to do is take our last 2 tests and combine them. So in other words, a number is divisible by 6 if it's divisible by both 2 and 3. Okay. So no number we've looked at so far fits this criteria. What about 102? Okay. 102, it ends in 2, so it's divisible by 2. Right. Its digits, the sum of them would be 1 plus 0 plus 2 is 3. 3 is divisible by 3. So it is divisible by both 2 and 3. Okay. So it is divisible by 6. Okay. So this is how we can combine rules. Okay. I mentioned earlier with 5 is another one you can do visually, because you're just looking at if the last digit is 5 or 0. Okay, so let's write that one down. A number is divisible by 5 if its last digit is 5 or 0. Okay. So this is another one we can just tell visually. We just look at the last digit. So for example, 102 is not this number, 1,03,456,895. It is, because all we care about is that last digit, and it's a 5. Okay. So this is. So speaking of combining rules, okay, 10 is equal to 5 times 2. So if a number is divisible by 10, it must be divisible by both 5 and 2. To be divisible by 5, the last digit has to be 5 or 0. To be divisible by 2, it's got to be 0, 2, 4, 6, or 8. So the thing that they have in common is that 0. If a number ends in 0, it'll be divisible by 2 and it'll be divisible by 5. And that's the only digit it can end in where it's going to be divisible by both of them. So a number is divisible by 10 if its last digit is 0. Okay. All right. So we have a bunch of rules now. So let's go through some numbers and look at what they're divisible by. One thing I do want to emphasize here is, just because we're saying a number is not divisible by 10 or something, it doesn't mean we can't divide it by 10. It means that when we divide it by 10, we're going to get a remainder. Okay, when we're talking about if something is divisible by 10, what we mean is if it is divisible by 10, that means we can do the division and we won't get a remainder. Okay. All right, so some examples here. The first one the book uses is 1290. So let's just go down our list. All right, these are the ones we learned. 2, 3, 5, 6, and 10. So let's test whether or not 1290 is divisible by all of these. Let's start with the easiest ones first, right? 2, all we have to do is look at the last digit. Is it 0, 2, 4, 6, or 8? It's 0, so yes, it's divisible by 2. For 5, is it divisible? Is it the last digit 5 or 0? Yes, it's 0, so it's divisible by 5. Since it's divisible by both 2 and 5, it's also divisible by 10. Alternatively, we could have went backwards. If we do the divisibility test for 10, we say, is it divisible? Is the last digit 0? And we would see, yes, it is. Because it's divisible by 10, it has to be divisible by 5 and 2, because that's how we make 10. All right, so now 3. 3 we got to do a little work for. We have to add the digits together. Okay, so when we do this, we get 12. Is 12 a multiple of 3? Yes, it is. Right, because you get 3, 6, 9, 12. So it is divisible by 3. Now, because it's divisible by both 2 and 3, we get that it's divisible by 6. Okay, so it actually was divisible by all of these numbers. Let's do one more example. Okay, 4962. Okay. So for 2, does it end in 0, 2, 4, 6, or 8? Yes. All right, it ends in 2, so it is divisible by 2. 5, I'm just doing the ones we can do visually first. 5, does it end in 5 or 0? No. Right, it ends in 2. So it's not divisible by 5. If it's not divisible by 5, it can't be divisible by 10 either. Okay, and you can also just check it doesn't end in 0. 3, we have to add the digits again. 4 plus 9 plus 6 plus 2. Okay, so 4 plus 9 is 13, plus 6 is 19, plus 2 is 21. Is 21 divisible by 3? Yes. When we do 21 divided by 3, we get 7. No remainder. So it is divisible by 3. So that means that because it's divisible by both 2 and 3, it's also divisible by 6. Okay. Okay, so there's a few more examples in the book if you'd like to try this on your own. It definitely would encourage that. And then of course there will be some on the homework like this. All right, so let's go on to the next section now. So before we move on, I just want to point out, because these are pre-recorded videos, feel free to pause them, right? And like pause and start so you can go at your own pace. If like I'm talking too fast, like on YouTube, you can change the speed of the video to 0.5 or something like that. Maybe I'll show how to do that in the future, but there's a change speed option, so you can just change the speed to like 0.75 speed, 0.5 speed, something like that, so that it'll slow it down if you like that. Alternatively, if you think I'm going too slow, you can speed up the video also. You can watch it at 1.5 times speed or 2 times speed. All right, let's talk about factors, right? Because this section was called multiples and factors. So we want to talk about now finding all the factors of a number. Okay. Actually, before we do that, let me just show you how to change the speed of the video. Okay. So I have here's our YouTube channel. So if we go on to this one right here, for example, right here is our most recent video. So you just want to go to settings, and then you go to playback speed. Here it's normal, but you can change it to any of these. So you can change it to 0.75. Welcome to today's lecture. And then it looks like, it's going in slow motion. So, alternatively, like I said, if you think it is too slow, you can change it to 2 times speed. If you can keep up with that, that's fine. We're gonna start with 2.2, but we did already. Maybe something like 1.5 or 1.25 would be a little more reasonable, so you can still kind of understand what I'm saying. A good like half of this chapter is. So yeah, that's how you do it. I think that is everything I wanted to show you. You can try the subtitles out. Those are just auto-generated, so they might not work too well. So that's up to you. All right, so let us go back now. All right. So the factors of a number. This is kind of just factors and multiples are very similar in divisibility. Okay. Here's our definition. If A times B equals M, then A and B are factors of M. Okay. This is kind of just like talking about multiples, but again in reverse. So for example, 9 and 8 are factors of 72, right? Because 9 times 8 is 72. And there's more factors than that too. So are 18 and 4 are also factors of 72. 36 and 2 are factors of 72 because all of these make 72. 3 times what is it, 24, I think? I think that's right. 24 and 3 would be factors of 72. There might be more. That's what, I think that might be it though. So you can see 72 has a bunch of different factors here. Okay. In the next section, we're going to talk about prime factorization. So we're going to break it down into all of its factors using factor trees. We're not going to do that quite yet. Let's look at a couple of other numbers, right? Like 102. So let's find the factors of 102. It's not super easy to do this without like an organized method because we're kind of just guessing at the numbers. One thing that can help us though are the divisibility test, right? We saw that it's divisible by 2 and it's divisible by 3. So we can use those as starting points, right? We know 102 is divisible by 2, so we can divide it by 2 using long division and see what we get, right? So we get 51. So 2 times 51 is 102. So 2 and 51 are factors. We know it's divisible by 3 also, so we can try that out. Right, so we just do the long division. 3 times 34 equals 102. So we have 2 and 51, 3 and 34. These are factors of 102. One thing the book, I don't think, tells you is that you only need to check numbers less than the square root of 102. So the square root is the opposite of squaring something. It means we're asking what times itself is 102. With a lot of numbers, there's no answer, so we do it in a calculator. So if I do it in a calculator, I get 10 point something. So this tells me that we just need to check the numbers from 2 through 10. In other words, we need to do the divisibility test for 2 through 10. This isn't so much something to worry about because in the next section, we'll have it a lot more organized. So we can find when we find the prime factorization, it's hard to like exhaustively check all the factors, but at least if you only check less than the square root of the number, then there's not that many of them. So what other ones could be a factor? Well, we know 2 and 3 both go into 102, so that means 6 also has to go into 102. So if we do 102 divided by 6, what do we get? Okay, we get 17. So we have 3 sets of factors here, 6 factors total. Is 102 divided by or divisible by 4? It wouldn't be. We didn't write down that test, but again, we can just check the last 2 digits to see if it's divisible by 4. 2 is not divisible by 4, so this is not divisible by 4. It's not divisible by 5 because it doesn't end in a 0 or 5. Same with 10. 7, there's not a test for. 7, we're just going to have to check by hand. It can't be divisible by 8 because it's not divisible by 4. And 9, we can do the similar test with 3. If we add the digits up, we get 3, which is not divisible by 9. So overall, it's not divisible by 9. So again, those are mostly tests we haven't done. So don't worry too much about that. I just want to show how you do it. We can test 7 manually since there's not a test for it. Whoops. And then 7 doesn't go into 32 evenly, right? So we have a remainder of 4. So this one doesn't work. So these are all of the factors. This is an exhaustive list. But it's hard to know that for sure. There's a lot of tests we need to do. So prime factorization, which we'll talk about in the next chapter, is a lot easier. So this section ends by defining what a prime number is. I think that's better in the next section because we're talking about prime factorization. So I'll talk about it in the next section. I think, yeah, we're good on time. So this is all we'll do for today. We'll do the rest of chapter 2 in the next section, prime factorization and least common multiples. And then after that, we'll move on to negative numbers. So thank you guys for watching this video, and I'll see you on the next one.